In this video, we'll review some basics about SQL and MySQL. Because everyone in the class already knows relational databases and SQL, we're not going to get into lots of details. We'll clarify some terminology, cover some basics, and just use some examples to brush up on your knowledge about the syntax of create, insert, select, update, and delete statements. We've been seeing that most web applications are data plus operations, and so far we've been storing data in the application scope. The good thing about application scope is that it's very easy to use. But the bad thing is that all the data will be lost when the server is stopped or restarted. And that's why real-world applications usually use databases, which are designed to handle large amounts of data safely and efficiently. Most of the databases we use these days are relational databases. There's lots of theory behind relational databases, but for us, the most important thing is that a relational database organizes data in tables. For example, suppose a company wants to keep track of the information about its employees and the projects they work on. In a relational database, this information will be organized into 3 tables like this. The first table contains employee information, and the second table contains project information, and the third table contains information about which employee works on which project. Later, we'll use this database to do some SQL exercises. But first, let's clarify some terminology. We call the software that manages database a database management system, or DBMS. There are lots of DBMS these days. You'll probably have heard of some of them, like Oracle, Microsoft SQL Server, and so on. In this class, we'll use an open source DBMS called MySQL or MySQL. A DBMS can manage a number of databases, and each database is a collection of data organized in tables. In addition to tables, a database may contain some other things like views, indexes, procedures, and triggers, and so on. These things are called database objects. Another commonly used term is schema. Depending on the context, schema may mean different things. In MySQL, a database is also called a schema, and consequently, database objects are sometimes also called schema elements. A table in a database is sometimes called a relation, and of course, a table has rows and columns. I'll sometimes refer to the columns as attributes or fields, and the rows as records or tuples or tuples. A table minus the actual data is called a table schema. Here's the term schema again. In this context, schema means the structure of the table. For example, here the schema of the table is the table name students and its 2 attributes, student ID and name. A database schema consists of the database name and all the table schemas in the database. Just like table schema, database schema refers to the structure of the database. And this is why when we say designing a database, we usually mean designing the database schema. The language used to access relational database is SQL or SQL, which stands for Structured Query Language. All relational DBMS support SQL, though each has its own dialect that is slightly different from the others. The good news is that the differences are mostly in the more advanced features like functions and procedural languages. The core syntax of SQL is pretty much the same across different DBMS. In this class, you'll be asked to place your SQL statements in SQL scripts. A SQL script is just a text file that contains SQL statements like select, insert, create tables, and so on. And let's quickly look at one. Okay, so as I mentioned, SQL script is just a text file that contains SQL statements and comments. Typically, the file has the SQL suffix, something like this. And inside, you would have SQL statements like select star from some table where something something. And you can also have comments like so this is in fact a SQL script. Note that SQL comments here starts with double dash and also a space after that. And in MySQL, you can also use slash star and star slash, just like in languages like in Java. But the standard SQL comment starts with double dash and followed by a space. And in this class, we'll be using MySQL as our DBMS. MySQL is arguably the most popular DBMS for web development. There are many factors contributed to its popularity. It's open source, it's optimized for query performance, it supports full-text search, it's very developer-friendly, and so on. The bottom line is that there are more people using MySQL for web development than any other DBMS, and that's the main reason we choose MySQL for this class. The MySQL on CS3 server is version 8. Each CS3 account you received at the beginning of the class comes with a MySQL database. The database is the same as the account name. For example, my account name is CS3220STU31, and that would be my database name. The username and password for the database are also the same as the server account username and password. Virtually all DBMS use a client-server architecture. The server part is the software that actually manages the databases, and we have to use some client software to access those databases. For MySQL, there's a command line client called MySQL, a GUI client, MySQL workbench, and a web client, adminer. Later on, you'll write Java code to access databases, and your programs are also considered database clients. Regardless of what client you use, you need to know the following information in order to connect to a database. You need to know the host name or IP address of the database server, the port number of the database service, username and password of the database account, and the name of the database you want to connect to. Remember, in MySQL, a database is also called a schema. Now let me quickly show you how to connect to your database on CS3 using adminer and the MySQL workbench. The easiest way is to use Adminer. It's a web application, so you only need a browser to use it. No software download or installation necessary. If you go to this page, there's a link down below that points to the URL of the Adminer web application. So just click on that. And here, leave system to default, leave server also to default. Remember, Adminer is a web application which also runs on CS3. So to Adminer, the database server is actually on localhost because both of them are running on CS3. So leave server empty, and the username would be your account username, and password would be your account password. You can leave the database part empty, and once we log in, we can then select the database here. So this is how we can connect to the database using Adminer, and later on we'll come back to this and use this to run some SQL statements. But before that, let's also try to connect using MySQL Workbench, because some of you probably prefer better looking GUI client. For MySQL Workbench, you first need to download and then install it, and then you can use it. So this is the link to download it, and after installation, you can run it, and it will show a screen like this. So notice that here it says MySQL connections, and we'll create a new connection. You can give this connection a name. The actual name doesn't really matter. Usually I would use a combination of username and then the host of the server. For example, here I would give it a name called CS3220STU31 at CS3, so that when I look at this connection name, I know which user and which server I'm using. And here, we'll need to change the host name to cs3.castdatela.edu. Notice that this one is different from Adminer because Adminer is actually running on CS3 itself, but this one is running on my local computer. So in order to connect to the database on CS3, I have to say the host name is CS3. Port number is the default port number for MySQL service. It's 3306, so leave it there. And the username will be 3220SU31. And the default schema, again, remember schema is another word for database in MySQL. So this one basically says which one we're going to connect to. So the database name is the same as the username. And for password, we can choose to store it in the vault. And next time we don't have to enter password again. So all set, and that should save it. And just click on that, and now it's connected. And context help. Do we need context help? Can we close it? Or just drag it? Okay, just leave it there then. Okay, so now we are connected. One word about MySQL Workbench is that it's very easy to try to open up multiple tabs in MySQL Workbench. Try not to do that because each tab will occupy one connection to the database. On CS3, each account has a limit of 4 concurrent connections per account. This is so that one account doesn't take lots of connections and overwhelm the server. So if you open up multiple tabs in MySQL Workbench, you can easily exceed the 4 concurrent connection limit, and later on, if you write your Java code, for example, it won't be able to connect to the database because you already used up all the connections with multiple tabs in MySQL Workbench. So remember, when you use MySQL Workbench, don't use multiple tabs, or at least keep in mind that you only have 4 concurrent connections allowed. Okay, so let's close this and go back here. Oh, yeah, by the way, if you want to change your password, this is a command to change it. Just say set password and then a new password, and it will change your password. You can run that command in here if you use adminer or the SQL editor in the SQL Workbench. Basically, you can run this as if it's a SQL statement. And in order to run SQL scripts, sometimes we need to do that. In adminer, you can select import and then choose file upload, and then choose the SQL script you want to run. And in MySQL Workbench, in the SQL editor, you can open up a SQL script file, and then it will open the content of the script in the SQL editor, and then you can execute it. Either way is pretty simple to do. Okay, so now that we know how to connect to MySQL, let's talk a little bit about database design. Properly discussing database design will take at least a couple of lectures, which would cover entity relationship model, ER design, converting ER design to relational design, and a few other things. Obviously, we don't have enough time for that. Plus, is something for a database class rather than a web programming class. So here we'll use a simplified design method, which I call database design for dummies. The idea is that we all know how to do Java class design. And to do a database design, we just need to convert the Java classes into some tables, following some simple rules. Let's use these 2 classes as an example. The first class is the employee class, and we have several fields: integer ID, string first name, last name, address, and each employee also has a supervisor, and a supervisor is an employee, him or herself. So we have a supervisor field here, which is an employee type. And the second class is project. Again, we have some simple fields like ID and name. And the leader of each project is an employee. So the leader field has a type of employee. And each project has a number of members, and members, of course, are also employees, so it's a list of employees. So this is a fairly straightforward class design. And if we have a class design like this, how do we convert it into a relational schema or tables? The first part is simple. Whenever you see a Java model class like employee or project, you just convert it to a table. So if you have a class called employee, then you would want to create a table called employee or employees. We'll talk about naming conventions in a moment. And then you look at the fields of the class, and you would want to convert the fields into attributes or columns in the table. So for example, for ID field here, you would want to have ID column here, first name here, first name here, and so on and so forth. And Java types become SQL types. For example, integer here is still integer here, but string in Java becomes a varchar or char field in SQL. So this part is pretty straightforward. You can almost just blindly convert a class into a table. But sometimes you'll run into a little bit difficulty. And for example, here, how do we convert supervisor into relational counterpart? Notice that the type of supervisor here is employee. We have something corresponds to integer and string in SQL, but there's nothing in SQL that corresponds to an employee type. You cannot create an employee column inside a relational table. There's simply no employee type. So what do we do when we see something like this? Now, the first thing to realize is that even in Java, this is not an employee object. When you say an employee has an employee as its supervisor, you are not really saying one object contains another object. Instead, this is something called a reference, meaning that it's not really an object inside the object. It's simply a reference or a pointer that points to another object, something that looks like this. So in a programming language, object references are basically references to memory locations, so you can go from one object to another. What's the equivalent of references in relational databases? Well, primary keys. So each record in a relational table corresponds to an object in your programming language, or in Java in this case. And the primary key field of each record is a unique reference for that record. So in Java, if you have a reference from one object to another, it's mapped to an ID field that can be used to locate another record. For example, here, this one simply says the object, employee object number 2 has a supervisor, which is employee with ID number 1. And that can be easily converted into relational table with this part becomes a ID, supervisor ID. And this supervisor ID uniquely identifies a record, which is the supervisor record of this employee record. Same thing here. So the second part of the schema design rule is if you see object reference fields converted into ID fields in tables. And then what about this list? Now, this list of employees is a collection of objects. Again, you cannot simply create a column inside a table and say this column stores a collection of something. That is not allowed in relational design. A column must have a simple type, like a string, like a number, and so on. It cannot be a collection type. So how can we deal with collections? Well, easy. You just put it in a different table. Technically, this is not always the case. If you know entity relationship modeling, and if you know the relationship types, many-to-many, one-to-many, many-to-one, and so on, you'll know that sometimes collections becomes a separate table and sometimes don't. But remember, we don't have time for all that, and this is schema designed for dummies. So for us, whenever you see a collection, create a new table for it. And it may not always be the most efficient way, but it guarantees to work. So don't worry about whether something must be a table or can be not a table. Just whenever you see a collection, create a new table for it. But that being said, it's not as simple as just creating a separate table, because you also need to maintain the connection between the new table and the old table. Meaning that in Java, we know that certain numbers belongs to certain project, but if you take all this into a separate table, you still need to have that information that says this employee objects or these records are part of this project. So this is why when we take all these employees and put it into a separate table, we also need to have an additional column here that references it back to the other table or to the original objects that owns these employees. So in this case, it's a little bit tricky because it's a list of employee, and remember, employees are references. So here, the separate table actually has a number of employee IDs, each one referencing an employee record. So if we take this one and convert it into relational schema, the members becomes a separate table, which has a additional column that references back to the project. So this part is a little bit non-intuitive. So you have to do it a couple of times in order to get the feel of it. But once you do it a couple of times, you'll see that it becomes more natural. So just keep this in mind. Collection becomes a separate table. Okay, so now that we have our design, let's brush up on some SQL syntax, starting with creating a table. So let's say I want to create a table called employees. So this is going to be my table, and actually I'm going to create this here using the SQL command window. So the syntax of create table statement is create table, and then followed by table name and parentheses, and inside parentheses field name and field type and optionally constraints. So if we look at here, let me see if I can make this larger. Okay. Here we can see that the table name is called employees, and it has a number of fields: ID, first name, last name, address, and then supervisor ID. And each field has a type. ID is integer, first name is varchar of 255, and so on and so forth. And then followed by some constraints like auto increment, primary key, not null, and foreign key. So, well, let's run this first to create the table. So it creates a table, and if we look at, let me make it smaller. If we click on the database, it will show the tables currently in the database, and now we see the employees table here. Now, there are a few things I want to mention about this create table statement. And first of all, the naming conventions. In Java, we have certain naming conventions. For example, when we create a class, we typically use singular form, capitalize the first letter, and so on and so forth. In relational databases, we typically use plural form for table names. So instead of calling it employee table, we typically call it employees. And we use singular form for column names. So it will be ID, first name, last name, instead of IDs, first names, last names. And often we use underscore to concatenate multiple words, for example, employee ID or first name. The reason for that is some DBMS treat names as case insensitive. So if you try to, for example, use the Pascal casing like in Java, in some DBMS, employee ID will look like something like this, which make it rather difficult to read. So it's better to use underscore to ensure that it's always easy to read no matter which DBMS you use. That being said, MySQL is actually one of those DBMS that treats names as case sensitive. So if you do employee ID, it will recognize it and display it as employee ID. So for MySQL, it's not too important to use underscore. You can use Pascal case like this, that's fine. But try to at least follow the first two naming conventions, plural forms for table names and singular form for column names. And then about field types, like integer, varchar, and so on. So just like Java, we have in SQL integer type and two floating point types, float and double, and then two commonly used string types, char of n and varchar of n. The difference between char and varchar is that char, if you choose the char type and with n characters, then no matter the actual length of the string, it will always use n characters to store it. If you use varchar, n is the maximum characters the system will use to store the string. If the string is shorter than n, it will use less storage space or less characters to store it. So generally speaking, when in doubt, use a varchar and use only char if you know for sure that all of the possible values have the same length. And you have the date type, time type, datetime type, timestamp type, and so on. So it's basically what they look like. If you just want date or just want time or want both date and time or timestamp, which for the most part you can consider it the same as datetime. Sometimes they have a little bit different range or accuracy, but by and large you can consider them the same for our purpose at least. Then auto increment, this is something that you'll probably use quite often. This, as the name suggests, when you insert new records into the table, the database system automatically automatically generate a value for ID, and it automatically increment the value. And this is quite useful when we want to have unique IDs. We'll see how this looks like in a moment when we insert some data into the table. And then the integrity constraints like primary key, not null, foreign key, and so on. So these are the so-called data integrity constraints, meaning that it constrain the data in certain way so that it makes sure you don't accidentally make a mistake and mess up the data. For example, the unique constraint says all the values in that column must be unique, and not null means all the values cannot be null, and the primary key is basically unique and not null. And then you have the foreign key constraint, which basically says a value in supervisor ID must be a value, must be one of the values in ID. That's what basically foreign key means, and this ensures that you don't accidentally enter a supervisor ID that doesn't exist. Okay, so that's a very quick review about create table statement, and then let's insert some data into the table. And there are two commonly used syntax for insert statements. One is we say insert into table values and then specify a number of values in parentheses. And if we use this syntax, the order of the values must match the order of the columns specified in the create table statement. And also we have to specify all of them. We cannot omit any one of them, even though some of those can be null, but we cannot omit it. If we use this syntax, these values must match these columns in order. If we only want to specify certain fields, in particular, if we want to let the database system automatically generate the IDs, we can use the second syntax, which says insert into table, and then we specify the fields, and then values, and then we specify the values. So in this case, let's insert something. So we can say insert into employees, and I'm going to use the second syntax so that we can let the database system generate the IDs for us. So we'll say, what are the fields here? First name, last name, address, supervisor ID. Okay, so we'll say first name, last name, address, and values. We'll say first name is John, last name is Doe, and the address is 123 Main Street. And let's insert another one. And this time is Jendo, same address. Execute. And Adminer has this very convenient panel that has a select statement, and we can just click on it, and it will run select from employees. So here you can see that we have inserted two records, and in both cases we didn't insert the ID. The system automatically generated the ID, and because we specified auto increment, it automatically creates unique IDs by incrementing from the initial value of 1. And we specified 3 column values and left the supervisor ID empty, and because of that, supervisor ID has the value of null. And if we insert one more, let's say we insert into employees, and this time we use the first syntax. We'll say insert into employees values, and the ID will give it 3, and the first name will say Tom, last name will say Smith, and address will say 234 State Street, and the supervisor will say 2. So if we run it and then select again, we can see that now we have another record, and this time the supervisor ID is 2, meaning that Tom's supervisor is Jim. So this is for insert statement, and if we want to do search, we can do select, then specify the fields, and then from tables where some conditions. For example, we can do, what do we want to do? Find the name and address of the employee with ID 1. Okay, so it will look something like this. We can say select, find the name and address. Okay, name and address. First name, last name, address from employees where ID is 1. So that gives us John Doe. And if we want all the columns instead of some of the columns, we can say star, and it will give us all the columns. So search is also known as query, and it's probably the most complex part of SQL. There are lots of ways to do search, and to master SQL, you have to know how to do various queries. In the next video, we'll actually talk query quite a bit more. So for now, just understand the basic syntax of select statement, select, and then fields, and then from more tables where more conditions. And then how do we do update? The syntax is update table, and then set field equals to some new value where certain conditions. And if you want to set fields, multiple fields, you can use comma after each field and value pair. So okay, so probably don't want to do either of that. And let's say we want to change John Doe's name to Jack Smith or something. Okay, so we'll do update employees, set first name to Jack, and the last name to Smith, and we have to pick John Doe, and we know John Doe's ID is 1, so we'll say where ID is 1. And this would change John Doe's name to Jack Smith. And the syntax is update table name and set field to some value where you select the records that you want to update. And that's for update. How about delete? Well, we can delete. So we can say delete from employees where first name is Jack. And if we select this again, we can see that now Jack is gone. So the syntax is delete from table name where you specify the conditions which will be used to find the record that you want to delete. And what about the whole tables? Well, you can use job tables to job tables, and you can also say job table if it exists, so that if you run this statement and if the table doesn't exist, you won't get a warning or error. So here, if we don't want to use the employees table anymore, we can say drop table employees, or we can say drop table if exists employees. Either way, it will drop the table, so no tables anymore. Okay, so that's a very quick refresher on the basics about SQL, some basic syntax and how to connect to database, and some terminology and stuff. In the next video, we will talk more about writing SQL queries. Okay, so this is it for this video. See you in the next one.